Thank you. I didn't even notice that. Okay, so hello. We are midway through our lecture on regex and destructive versus non-destructive methods. So I was just looking at the difference between matching versus searching using the regex library. And let's see what it says here. It offers two different primitive operations based on regular expressions. Match checks for a match only at the beginning of the string, while search checks for a match anywhere in the string. Okay. So if I did replace June 24th here with dates, like so, and did that for both of these, let's see what happens now. There we go. So search found August 1st, and match didn't find anything.
So that's how you test. If you're doing logic, you would say if not none, then it found a match, basically.
Yep. And there's other ways to interact with this match object as well that we'll get into. Like I think we should be able to say, if we do research dot match, I believe. Okay, it doesn't do that. Let's take a look at it. Okay, so if we did dot match. So they have something called dot group, which I believe if I do dot group like this, so we're printing out dot group, clear. There we go. So dot group just gives me just the thing that it found rather than everything, rather than that match object, that is. So they're using dot group, you can get the actual string out of the match object.
Noah, do you have to declare a separate regex pattern variable, or could you just drop that regex right in where you have it, wherever you have the variable?
Yeah, you can just drop it in right here instead if you want. I just wanted to save it as its own separate variable so we don't have, so this doesn't get too crowded. And that allows us to kind of look at this on its own.
Hey, Noah, I kind of missed it at first. The R, like line 6, the R before your regex statement, what did that stand for again?
So this makes it into a raw string, because in a not raw string, something like if we did \n, it would just immediately insert a new line in there instead of reading a new line character into that. But with an R, we'd be able to say, okay, this is a new line character, treat it as we would anything else. So using a raw string, you could search for a new line character within a string, for example.
Gotcha.
So raw string is just another data type that's related to string, but has slightly different rules. All right, let's try another example.
I'm sorry, why is it that pattern isn't finding excuse me, pattern isn't finding anything now that you put dates there?
Okay, so it's the difference between the search and the match function. And if I'm reading it right, search will return the first one it finds, while match will only look at the beginning of the string, and if it's not there, then it'll just say, nope, couldn't find anything.
Got it. Okay, thanks, sorry.
Or maybe I have it backwards. Yeah, match only looks at the beginning of a string, search checks all in the entire string.
Got it. Sorry, thank you.
No problem. No need to apologize. All right, so first off, once you find everything, we could do, say, something like this: matches equals re.findAll. And then you can loop through it pretty simply by saying for match in matches. Should call this matches. I could say just print full match is one of these matches. And we should be able to see kind of a better example here. So we can loop through the results of a find all like you would anything else. And again, it's a tuple as opposed to any other type of thing, but that shows us all of the matches it finds. And there's other things we can do with regex as well. We can also, for example, manipulate strings as well as just searching through them. So I'm going to make an, actually I'll use the same pattern. So I'll just keep regex pattern as is. And let's say what I want to do is I want to rearrange my these dates, June 24th, August 1st, December 22nd, to make it 24th of June, 1st of August, 22 of December. I'm not going to worry about the TH and the ST. That's a little too much. So I'm going to use another method. I'm going to call this one, this is re.sub. And re.sub lets you change things up a bit. So the first thing I'm going to get of it is my regex pattern saying, okay, the first argument is what pattern to look for. And then the second one argument is how to change it. In this case, what I want to do is I want to rearrange things. And one reason we put these in parentheses, like so, is that makes these two patterns, the date, the month, and the day, into separate groups. And using groups, you can change things around like so. So I'm going to put a raw string. I want to say put group 2 here, and then put of group 1. And then the final argument is going to be, get out of here, is going to be this string. Whoops. Like so. So now if we watch this in action, 24 of June, 1st of August, 22nd of December, 22 of December, that is. Because again, in our pattern, this, because of the parentheses, is group 1, and this one is group 2. If we didn't use these parentheses, it wouldn't be able to do anything with that using these groupings. But they're potentially very, very powerful. And again, regex is like the way things you can do in regex are potentially limitless. So if you go to pythex.org, we've got all of these things like quantifiers, special sequences, like so. So while you're doing today's challenges, you're definitely going to want to keep this open because it'll really help you kind of notice these things. And regex is just a very, very deep well to go to. So I'm only scratching the surface here of what regex is capable of. I just want to kind of introduce you to the concept and how it generally works before letting you study it on your own with today's challenges. But before I move on to the next section, what questions do you have about regex that I can help with now?
Can I see your regex expression again?
This one?
Yep, just right there for a sec.
And you're not expected to memorize regex patterns.
Yeah. Very few people ever do.
It's rarely ever used unless you're doing some form validation.
Yeah. And it's one of those things that when I mentioned how you want to make sure that user input is properly formatted. This has been solved so many times that most languages already have methods for detecting whether something's a valid email or a valid phone number, but they're almost definitely using regex in the background. So it's good to know how to use it.
On job interview, on software engineering job interviews, are most of the questions like logic, just basic coding logic questions, and they're testing your logic, or are they because there's been a couple of things you've said, oh, you don't need to memorize this, you'll always be able to look it up. But one situation where I can imagine you not being able to look it up is a job interview. Do they stay away from things like regex and other like pure memorization items?
I don't want to say that like none of them will, because who knows, but I've never had to use regex in a single job interview before. Most of the questions I've been asked have involved logic, algorithmic logic, or in certain cases, things like database visualization, which we're also going to teach you later on.
Yeah, if they ask you a regex question in a job interview, I'd personally just walk out.
Yeah.
Well, you've got a job, Tom.
They didn't ask me a regex question.
Hmm.
I'm not sure who asked the question, but I've been working in cybersecurity for a few years, and we use regex all the time to find IP addresses or anything, and we just template all of them and then just cut and paste. We have like 5 or 6 that we use all the time, and then we just nobody really. I mean, we have cheat sheets if we needed the right one, but it's rare. We just copy and paste the ones that we already made.
Yeah, that's a good thing about regex is once you find the pattern that works for a particular problem, you just have it, and you can hold on to that for as long as you need it.
Hey, Noah, can you go over the, can you scroll up or actually scroll down in the loop where you print out the matches?
Mhm.
If we want to access, that's going to print a list of tuples. If we want to access individually each item and each tuple, how
Yeah.
can we do that? Like index 0, index 1 in each tuple?
Yeah, that's one way to do it. So you can just do 0 and then match 1, because tuples accessing individual values works just like a list. And you can also loop through a tuple. Don't think you can do that necessarily within string interpolation, but yeah. So tuples, when it comes to just reading the data, work just like lists. The only difference is you can't manipulate a tuple at all. You can't change any values. Okay. There are no more questions about this. I'm going to go on to talk about destructive versus non-destructive methods. So this is a concept that applies to every coding language. Every coding language has methods that are destructive and methods that are non-destructive. So the idea is a destructive method always changes the original data, and a non-destructive method doesn't. And kind of the reason we talk about this is it's always good to know whether or not you are changing the original variable or not. And this kind of all comes back to how data is stored in code. Essentially, it's saying, okay, whenever I do something to a variable, am I overwriting it in memory? Or am I creating a new variable in memory and leaving the old one still where it is? So I could say, first name equals Noah here. And if I run first name dot capitalize, so if I print out first name, we can see the first name variable was left as it is. We ran first name dot capitalize, which returned the version with just the first letter in uppercase. But that doesn't change what happens to my original variable. This is a non-destructive method. So if I wanted to hold on to this, I would have to save it to a different variable, like capitalized, if I can spell, like so. And that would allow me to save the capitalized version as a variable. All right, and I can try another version where I could say, last name equals Heinrich, lowercase. And I could say last name dot replace. I'm going to replace all of the I's with 1, 2, 3. So if I print that, and then if I print last name, we'll see that last name is unchanged, because this is a non-destructive method. It leaves the original untouched. But I can also create a destructive method by saying, staff equals John and Noah and Tom. And I could say staff.append rod. If I print staff, the original variable has been changed. Now we have staff is now completely different than what it was. So this is a destructive variable. It's a destructive method. And we can also do staff.pop and then print staff again. And it's been changed all over again. So most methods involving arrays like this, they alter the original in some way, and therefore they are destructive methods. All right. So in general, like there isn't necessarily I wouldn't say that one is better than the other. There are reasons to use both methods, both destructive methods and non-destructive methods. It's just important to realize what each method is kind of method is doing, and also to make sure that when you're defining your own methods, you know whether it's destructive or non-destructive. And as we move forward into more frameworks, you'll find that there are many times when a destructive method or a non-destructive method is required. So an example of that would be in React. When you want to change what data is stored in React, you can't use destructive methods. It won't let you do it. So you'll need to be able to define it as a non-destructive method. So what questions do you have about destruction versus non-destruction? All right, so yep, that's just an important thing to know as you go forward in your career. Where did today's, all right. So let's talk about today's challenges. So the destructive methods aren't really part of that. So your assignments, your first one is to go over this website, Regex1. So if I open link in a new tab here, Regex1 is a great way of learning regular expressions. So they have several lessons to go through. So for this first one, for example, it'll say, okay, you need to find a pattern that will match with all three of these lines. So A, B, C, D, E, F, G, A, B, C, D, E, and A, B, C. So all of these have something in common, right? A, B, C. And it'll tell you if you pass, then you hit continue. And then you can say, okay, what is the common variable that all these have? So it also has lesson notes here about what each of these things do. So go through so essentially just keep on continuing until you can't continue anymore. And then you'll have two other regex phone numbers is a regex challenge. So this is one that focuses on learning regular expressions. So it's got several methods that you'll need to make. So one is has phone number. So checking if a string contains a phone number at all. One is getting the phone number from a string as opposed to just checking whether or not it has one. So one returns a phone number and one returns a Boolean. There's a get all method for getting all of the phone numbers. One that's kind of hide phone numbers. So it says hide all numbers in the phone except the last 4 digits. So changing this into a phone number into XXX1234. And then finally, there's format phone number, which is get the string of the phone number and format it to our pretend application. So you want to change 312-111, all of these different formats. They should all be using the dash format. And then stock picker is more of an algorithmic question for both JavaScript and Python. So you'll get a list of stock prices, one for each hypothetical day. And it should return a pair of days representing the best days to buy and the best day to sell. So it's for example here, so stocks go up and down from 17 to 3 to 6 to 9 to 15. And so the best days are day 1 when it's worth 3. And the best day to sell is day 4 where it's worth 15. Because $15 minus $3 is a profit of $12. And of course, we're going to need driver code in the spec file to unit test ingest. All right, any questions about today's challenges?
For phone numbers, since the test specs, the unit tests are already written, an easy way to, instead of getting overwhelmed by all the failing tests, you can either comment out all the test specs except for the one you are currently testing, or there's another way to do it, Noah, like the one that where it fails for it fast or whatever.
Yeah, let me look that up exactly how to, so be Python unit test fail fast. There's a way essentially to say stop after failing first test. Well, that's PyUnit, that's different. Okay, that looks better. Because I know it's like a certain thing you got to add to it that will do that. No? Well, that doesn't help. Python unit test fit module fail fast code example. All right, this one doesn't seem to be having our thing either. Is it? Because we want to say Python unit test exit after first failure. Stop on first failure. Let's see what that says. That's PyUnit. Let's see if it's anything different. No, that's something else. Well, it's using unit test. All right, so it's there. Command line options. Aha. Okay, so it is just -f. So you do Python unit test.py, and then you just do -f. And that'll make it so that after the first, once you hit one failure in your code, it'll stop. So that way you can just tackle one error at a time. So yeah, you want to use -f there, and that'll make your life a lot easier. All right. Any other questions before I let you get started on the challenges?
If we use green for that unit test at the end, will the -f still work with that?
I imagine green probably has its own command. It may also be -f. So I'm sure there is some way to say use the green library to fail fast as well. You did like, Python green fail fast. Let's see what the official GitHub says. See if they have anything there. So they have green, config files, troubleshooting, integration. They have a lot on here. Very, very well documented. Good job. So if I did, fail. All right, I'm not seeing anything here, but that doesn't mean it doesn't exist. It just needs to do a little more.
Yeah, the green should, if you just do F, it should fail fast.
Okay. Thank you, Tom.
I just tested it real quick.
Yeah, I should have thought of that. All right. And also, we have a lot of resources here on Regex. So if you ever get stuck on any kind of Regex problem, either today or forever, have a couple of these in your back pocket. They're all super useful. Again, Pythex is really, really good, really good for that. Regex 101. There's a tutorial here from Data Camp. One other thing I like is there's a website called Regex Golf, which is like a challenge thing if you ever want to try that. So it's like, all right, match all of the things in this one and match none of them in this one. And it starts out easy and gets really, really difficult the further you go. So if you ever are bored and want to just really stretch your regex muscles, go look for regex golf. So like something like this, where you have to find all of these but none of these. That's where you can see where it gets a little more difficult. All right. So I'm gonna stop